In this video, I'm going to do a brief demonstration of the Brayton Cycle Simulator. First, I want to just orient us to the various blocks of information available in the simulator. This block of information is the operating parameters. These are all the settings that you can change to change the behavior of the Brayton cycle. We'll be returning to discuss these in detail later. The next block of information are all the outputs. First, there are the state points at various points around the cycle. These include the pressure, temperature, enthalpy, and entropy. The next set of outputs is the operating conditions. These include all the work and heat transfers in various components, as well as the back-work ratio, the thermal efficiency of the cycle, and the Carnot cycle, or the efficiency of a Carnot cycle operating between the same two temperature limits. The next block of information here is a TS diagram, and the final block of information is a schematic diagram of the layout of the components for the current Brayton cycle that we're simulating. I'm now going to demonstrate the simulator by going through the operating parameters one by one. The first block of operating parameters that we can change are all the pressures. There's the ambient pressure. That's the pressure at the inlet to the compressor down here and at the discharge of the turbine. Next is the combustor pressure. So that's the pressure in the combustion chamber. Finally, there are intercooler and reheater pressures that will become active when we turn on intercooling and reheat later on. There are 4 different temperatures that we can set. There's the compressor inlet temperature. That's the temperature of the air when it enters the gas turbine. There's the turbine inlet temperature. That's the temperature at state point 3. Notice that's how we control the amount of heat being added in the combustion chamber in the simulator. Next is the intercooler and reheater delta T's. These are the temperature increases across the intercooler and reheater, and you'll notice by default those are set to 0, so there is no intercooler or reheater in the system right now. We'll show those a little bit later. The next thing we have control over is the mass flow rate, and the default value there is 1 kilogram per second. But we can change that all the way up to 100 kilograms per second if we wish. Next is the efficiency of the compressor and the turbine, and again by default those are 100% efficient. Next is the regenerator effectiveness, and again notice the default value is 0, which means there is no regenerator in the system. Finally, we can choose either an air standard analysis where all of the properties are the ideal gas properties of air, or a cold air standard analysis, where all the properties are the properties of air, but with a specific heat at constant pressure assumed to be constant at 1.007. We can change this value of Cp if we wish for the cold air standard analysis. The final thing in the input block is a reset button. And if, at any time, we want to get back to these default conditions, we just hit that reset button and it'll return everything to its default value. Now we're going to change some of these inputs and show what effect they have on the cycle. The first thing we'll change is the combustor pressure, and you'll notice that as we increase the combustor pressure, this pressure increases. Notice that the TS diagram only shows 3 processes: the compressor, the combustion chamber, and the turbine. The second fictitious heat exchanger that takes us back from 4 to 1 is not shown because it's not part of the gas turbine schematic. Next, we'll show what happens when we turn on the reheater. We turn on the reheater by just adding some reheat. So you'll notice the first thing that happens is that a reheater is inserted between 2 turbine stages. Now we're adding heat in the combustion chamber, but we're also adding heat in the reheater. We have control over the amount of temperature increase there is in the reheater, and you'll see a reheater has now appeared on the TS diagram. We'll increase the amount of reheat, and you can see the first turbine stage, heat added in the reheater at constant pressure, and then the second turbine stage down to 0.6. And while we're changing these parameters, the value of pressure, temperature, enthalpy, and entropy are being updated, and any additional work and heat transfers that happen are being updated here. You'll notice we now have a 2-stage turbine, so the power output of the 2 stages is reported separately. We can also add an intercooler the same way by changing the temperature decrease across the intercooler. There's our first stage compressor, the intercooler, the second stage compressor, and then on to the combustion chamber. In the schematic diagram, an intercooler has been added into the system. We can also add a regenerator by increasing its effectiveness from 0 up to some number, and you'll see the regenerator has now shown up in the schematic diagram. This is the regenerator. The air coming out of the high pressure compressor goes through the regenerator and gets preheated before it goes into the combustion chamber. And it's being preheated by the exhaust gases before they exit to the atmosphere. On the TS diagram, the yellow lines are now showing what's happening in the regenerator. The temperature of the exhaust gases is being cooled down from 9 to 10, and at the same time, the compressed gases are being preheated from 4 to 5 before they enter the combustion chamber. The last thing we'll show is the effect of compressor and turbine efficiencies. I'm just going to reset this back to default conditions so we only have a single turbine and a single compressor. If we decrease the turbine efficiency, we will see that now, as the turbine expansion occurs, this line drifts off to the right. If we decrease the compressor efficiency, the same thing happens. As the compression progresses, the entropy increases and the line drifts off to the right. I hope you enjoyed this video. There's a link to the simulator in the description if you want to try it out for yourself.